Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 5, Section 4, titled Writing a Function Rule. By the end of this video, you will have reviewed processes for writing function rules. You will start by reviewing processes for writing function rule from a table. You will then look at two real-world problems regarding function rule creation and application. If you'd like me to cover any of these topics in greater detail, please leave a request in the comment section below. Please subscribe to my channel if you find this video to be helpful. Thank you. Okay, Objective 1, Writing Function Rules. You can write a rule for a function by analyzing a table of values. Look for a pattern relating the independent variables to the dependent variables. We'll take a look at that in the next slide. Okay, example 1, writing a rule from a table. So thinking about what we just saw on the previous slide, it said you're going to look at the independent variables and say, what can I do to the independent variable to make it look like the dependent variable, so to speak, right? So let's take a look at this. It says, write a function rule for each table. The first table we're looking at. It says here, ask yourself, what can I do to 1 to get 5 or to 2 to get 6? Well, you look on the table, you see the first one right here is the 1. And to change a 1 into a 5, you're going to, well, you can certainly add 4, correct? And that's what we're going to find out that you're doing. It says you can add 4 to each. Well, from 2, you get to 6. Oh, that's okay. Add 4 to the first, add 4 to the second, the third the same. Oh, 3 plus 4, 7. Okay, there's the rule. You take whatever the independent variable is and add 4 to it. Well, let's write that function rule. What is the function rule? Well, we're going to relate these words that we just came up with. You can add 1 or add 4 to 1 and add 4 to 2 to get the answers. So we can say f of x, and they ask you that, get the f of x value, right? So f of x is equal to x plus 4. Well, in our case, it was 1 plus 4, 2 plus 4, 3 plus 4. And right, so we related, that's the word, so we're going to write f of x equals x plus 4. And here it is, the rule for our function is f of x, I'm going to change colors on the slide, f of x is equal to x plus 4. Let's look at the next one. Ask yourself, what can I do to 3 to get 9? To 6 to get 36? Oh, what can I do? So 1 gives me a 1, okay. 3 gives me a 9. Well, if I add 6, but I can't add 6 to get 36. So it looks like I have to do some multiplication because what? I take a 6 and I have to get a 36 from it. And can't add something because you can tell right away that it's not something that you can add or subtract. So it looks like 3 squared is 9. 6 squared is 36. That's why it helps to know your multiplication tables. Take this opportunity to think, oh, I can get my multiplication tables, study them. It's going to help in these types of problems. 9 times 9 is 81. There it is. So you can multiply each x times itself or square it and get f of x values, right? So f of x, y equals, it says f of x values, but here they have y's, but it doesn't matter. Y equals x times itself. Y equals x squared. And there's our answer. The rule for the function is f of x equals x squared right there. I'll try to underline it. F of x equals x squared. Okay? There we wrote our function rules. Okay, now we're in example 1, check your understanding. So we're going to check your understanding. And as you know, I like you to, if you've been with me in the past on previous sessions here, I want you to pause the video and work this out. And when you get back, we'll do them together. So they have 3 problems, 3 tables, and they'd like you to come up with the function rule for each table. Okay? So why don't you go ahead and give it a try, and when you get back, we'll do it together. I'll wait. Okay, now that you've paused and completed the tables and come up with your function rules and you're back, let's go ahead and let's see if we can make these look look good to, okay, let's see if we can figure them out. So what do we have here? We have, in problem A, we have x and f of x. So x is 1, f of x is -1. Okay, well, what could we do there? We could multiply by a -1 and get 1 goes to -1. We can subtract 2. From 1 to -1 is 2. So now the next one, that was 1. What is 2? 2 says, oh, 2 and you get 0. Oh, well, the first one was 1 minus 2 is -1. 2 minus 2 is 0. 3 minus 2 is 1. Okay, we found it. Our function rule, f of x. And we know it's f of x because right here they started with f of x. And what does f of x equal? F of x equals x is the input value, our independent variable. And are we adding or subtracting? We're subtracting. We're going to subtract 2. That is our function rule for that table. Let's do the next table. Okay, now we're going to be doing a y. Okay, I'll write the y. Y equals what? Well, it's going to be equal to something with an x. So we look at the first value. 1 to get to 2 is you could add 1. Okay, or you can multiply by 2. If you had 2, you can't add 1 to get to 4, but you can multiply by 2 to get to 4. 3. Oh, you have a 3, you can multiply by 2 to get a 6. There's our answer. Y is equal to x times 2 or 2x. Okay, let's do the next one. Again, we see that they're looking for a y. So I'll go ahead and start by writing a y. And that y equals, so we look at our first one. 1 gives us a 3. Well, 3 is 2 higher. So it could be 1 plus 2 or 3 times 1. How about 2 to get us a 4? Oh, look at that. So it was 1 plus 2, 2, oh, plus 2 again, 3 plus 2 again, 4 plus 2. So in each case, it is our x value, our independent variable, plus 2. Okay, those are our 3 function rules for example 1. Okay, example 2. Here's one of our real-world problems. We know there's 2 of them in this section, so they're fun. These real-world problems are kind of fun. So let's look at it. It says the exhibit at the right. There's our picture at the right. Okay, is a scale model of a desktop computer. As you see, it looks like these kids are playing on the keyboard, right? Look at that, and they're like, I don't know if it's the same children dancing up in the monitor or not. I can't tell, but it is about 20 times the size of a normal size desktop computer. So it's 20 times larger. Okay. Write a function rule that describes this relationship. So they just want the function rule. What is the function rule that'll give you something that's 20 times larger than what you started with? Okay. So you relate right here. It says function rule to describe the relationship. Relate. Larger is 20 times the normal. So what that's saying, the larger version of the computer is 20 times larger or bigger than a normal size computer. Let n equal the length of a normal size computer, and let L of n equal the length of the large size computer shown in the museum. Okay, and write L of n, L of n is equal to 20n. So that's our function rule. It's the bigger model, the scale model, which is 20 times larger, is 20 times the size of the normal size computer. Okay, which is the length of a normal computer. And there's nothing more you can do. That is the function rule. So the function rule, L of n is equal to 20 times n. And that describes the relationship between the normal size computer and the large museum computer. Now, how about problem B here? A space bar on a normal size computer is 4 3/8 inches long. About how long is the space bar on this exhibit? Okay, so we're going to take our function rule that we just created. Right, here's our function rule from above. L of n is 20n. So now we're going to substitute in our variable, or in this case, it's our independent variable, n. We're going to put in 4 3/8. Depending on how you want to do it. If you want to do it with the calculator, it could be 4.375 if you wanted to do that. But regardless, it's L of n is equal to 20 times 4 3/8. And according to that, when you do the mathematics, you'll find out that it's about 87.5 inches long. It's a pretty big space bar, right? So the space bar in the exhibit is about 87.5 inches long. Okay, example 2, check your understanding. So we'd like you to go ahead and give this a try, okay? What does it say? It says, I'll read the problems first before you go try it on your own by pausing the video. A carpenter buys finishing nails by the pound. Each pound of nails costs $1.19. Write the function rules to describe the relationship. And then the second problem is, how much do 12 pounds of finishing nails cost? So you'll write your function rule, and then you'll use that function rule to solve a problem. So I'll go ahead and wait. You go ahead and try it. Okay, so what do we have now that you're back? Carpenter buys finishing nails at or by the pound, right? Each pound of nails is $1.19. So I don't know, we can pick whatever variable we want, but why don't we say that the function of what? The number of nails is equal to 1.19 times the number of nails, pounds of nails that you buy. And that literally is the answer. F of n or C or whatever you want to pick here is equal to 1.19 n. And now if you're going to try to put it in B and solve this, you're going to say, okay, we're going to say that, let's do the price, I guess, all right? The price of n pounds of nails is equal to 1.19 times 12. And 1.19 times 12, I'll make that dot a little bigger, times 12 is equal to 14, if you use your calculator, 14.28, or just do the multiplication, and it's dollars. So 12 pounds of finishing nails would have cost that carpenter $14.28. So there it is. You've created the function rule over here. Here you created your function rule, and here you used it to solve a problem. Okay, example 3. Here's our second real-world problem. Okay, suppose you borrow money from a relative to buy a lawnmower that costs $245. You charge $18 to mow a lawn. Write a function rule to describe your profit as a function of the number of lawns that you've mowed. So that's saying, how much profit will I make if I mow 100 lawns, right? At $18, right, per lawn? But there's also something you have to think about. What? And that's the cost. You don't have profit until you paid for your power mower, right? So let's relate the total profit right here. Total profit. Maybe let's, yeah, okay, I'll just do that. Let's see, what can I do there? Can I do this? I want to do something here. I've never done this. What is, let's see. If I take here, this is interesting. Total profit, which is this right here, P of n, is what? Is stands for is equal, right? Is equals right here, equals. And now I'm going to pick green, $18 right here per lawn. Here's the 18 per lawn. And I'm going to do this darker blue. And here is the number of lawns times that dot right there. Lawns mowed. And you have to subtract out of that minus, here's your minus. And finally, we're going to say, let's do this light green. The cost of the mower, right? Here's the cost of the mower is $245. So there's total profit is $18 times the number of lawns minus the cost of the mower. Define define N, it's the number of lawns mowed, and P of N is the total profit, right? And there's our equation. Here's our equation. Now I'm going to go back to the pencil. That was fun. I don't normally do that. So there it is. It's P of N is equal to $18 times the number of lawns you mow minus the $245 that you had to spend to start your company. There's your function rule. So here, reading it, the function rule, P of N is 18 minus 240, 18N minus 245, describes your profit as a function of the number of lawns mowed. Okay? Okay, example 3, check your understanding. So it's your turn. Suppose you buy a word processing software package for $1.99, not $1.99, excuse me, $199. You charge $15 per hour for word processing. Write a rule that describes your profit as a function of the number of hours you work. So P of N, we're going to call it profit for the number of hours, right? So what are we going to write? We're going to write right here, we're going to say P of N, profit based on the number of N is the independent variable, is what? $15, right here, $15, 15 times the number of hours, I said, times the N times the number of hours, but you have to subtract that initial cost, and the initial cost was $199. This is our function rule right here. P of N is 15N minus 199. Okay, if you work 10 hours, you'd make $150. You still would not have paid off the mower. Okay, 18 hours won't pay it off. 19 hours you will just have paid it off and earned a little bit of extra money. Okay, you've done a good job.